Welcome to the chapter Knowing Our Numbers.
This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to
Understand comparison between numbers. Estimate rounding off numbers. Identify the place value of numbers. Expand the numbers. Illustrate usage of commas. Differentiate Indian and international system of numeration. Understand the large numbers used in our daily life. Describe the units of lengths, weights and liquids, etc. Know the expansion of braces. Write the numbers in Roman system.
Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to know more.
In lower classes, we studied about numbers and operations like addition, subtraction, multiplication and division. Do you know how to find the place value of digits? In this section, let us know how to identify the place value of digits and comparison between the numbers. Let us know how to estimate and compare numbers. As we already know that the number 9 is greater than 8. Now, let us find the comparison between two numbers in case of higher numbers. For example, let us consider two numbers 65895 and 64982. To compare these two numbers, first check the digits which are in 10,000s place, that is 6. Here they are same in both the cases. So go for next value which is in thousands place, and now again by comparing these two digits, we observe that the number 5 is greater than 4. So, we conclude that the number 65895 is greater than 64982 number. Let us do a simple activity to find the greatest and the smallest numbers. In the first question, all the options are 4-digit numbers, except the second option, that is, the 5-digit number, and hence 89575 is the answer. In the second question, only the third option's first digit starts with 4, which is the least number in the given options. Hence, 4546 is the answer. Let us know how many numbers we can make from the given set of numbers. For the given set of individual numbers, do you know how many numbers can you make? Can you illustrate the greatest number among them? For example, if two given numbers are 4 and 7, then the possible two sets of numbers are 47 and 74. Let us see the rules in making numbers. Rule 1. Suppose 0 is one of the digits, then we cannot make a smaller number starting with 0. In such cases, the first digit will be a number greater than 0 and less than the other digits. Example: if 0, 5 and 2 are the given three numbers, then the possible set of numbers are 205, 250, 502 and 520, which are in increasing order. Rule 2. The digits in the number should not be repeated unless they are given. That is, if the given sets of individual numbers are 2, 4, 2, then the numbers can be formed as 422, 242 and 224, which are in descending order. Rule 3. If all the given set of numbers are same, then we can make the numbers as only one set. Let us know about shifting the digits. Let the number be 325. By shifting the digits, we can make largest possible number as 532 and smallest possible number as 235. Similarly, by shifting the digits in the number 364, we can make 6 sets of numbers as shown. Here we observe that to get the greatest number, we will first see the greatest number in hundredth place, that is 6, then comes the second greatest number in tens place, that is 4, and the remaining number in the ones place, that is 3, and the greatest number is 643. Similarly, to form the smallest number, we will put the smallest digit in the hundreds place, that is 3, the bigger number in tens place, that is 4, and the greatest number in ones place, that is 6, so that the smallest number is 346. Let us perform an activity to know ascending and descending order of the given numbers. Drag and drop the given numbers in the ascending and descending order and click on Submit button to verify answers. The arrangement of numbers from the least value to the greater value from the given numbers is known as the ascending order. The arrangement of numbers from greater value to the least value from the given numbers is known as the descending order. Activity 3. Appropriate comparison symbol. Select the appropriate comparison symbol. Introducing 10,000. We know the greatest single-digit number is 9, and there is no single-digit number more than that. And the greatest two-digit number is 99. Beyond that, there are no more two-digit numbers. Similarly, the greatest three-digit number is 999, and the greatest four-digit number is 9999. Now observe the pattern shown on screen. We observe that the greatest single-digit number plus 1 is equal to smallest two-digit number. Similarly, the greatest two-digit number plus 1 is equal to smallest three-digit number, and greatest three-digit number plus 1 is equal to smallest four-digit number. Similarly, the smallest five-digit number is obtained by adding 1 to the greatest four-digit number. Let us revise the concept how to expand a number using place value. For example, look at the number 85. Here, 5 is in ones place and 8 is in tens place, such that by multiplying the digits with their respective place values, we can expand the number. Now, look at the number which is a 3-digit. Here, we have 9 in hundreds place and just multiply it with 100. Same will be applied for 1000-digit number, 10,000-digit number, and so on.
Knowledge check. Attempt the following questions to check your understanding.
Introduction to large numbers. The greatest 5-digit number, what we all know, is 99,999. Now, just add the number 1 to it. Then we will obtain the least 6-digit number, that is 1 lakh. Let's take the number 456789. Its expanded form is as shown. We will read it as 4,56,789. Now, let's listen to the conversation between two friends.
Hi Vinay,
Hi Vandana.
do you know what is the least 7-digit number?
Yes, it is 1000000.
Do you know what is the highest 7-digit number?
Yes, it is 9999999.
What will happen if we add 1 to that number?
If we add 1, it will become 1 crore, which is the smallest 8-digit number. Let us do an activity on identifying tens, hundreds, thousands in a lakh. Choose the appropriate options for the following questions. Tens in 1 lakh is 10 into 10,000, which is equal to 1 lakh. Hundreds in 1 lakh is 100 into 1000, which is equal to 1 lakh. Thousands in 1 lakh is 1000 into 100, which is equal to 1 lakh. Place value of larger numbers. Let us now see the places of larger values. Here is the number 54987944. Let's see how it is placed with their place values. Here, 5 is in crores place, 4 is in 10 lakhs place, 9 is in lakhs place, 8 is in 10,000s place, 7 is in thousands place, 9 is in hundreds place, 4 is in tens place, and 4 is in ones place. Now, it can be read as 5 crores 49 lakhs 87,944. The following table shows the numbers up to lakhs and crores. From the above table, we observe that 1 crore is equal to 100 lakhs, which is in turn equal to 10,000 thousands. 1 lakh is equal to 100 thousands, which is equal to 1000 hundreds. Let us do a lab activity to know the numbers and their place values. Click each tab to know more. The objective of this activity is to know the numbers and their place values. The materials required for this activity are a paper strip, a pencil, and a pair of scissors. Let us consider the number 4, 5, 3, 2, 8, 1 to know the place values. Take a paper and cut it to make a strip and fold it as shown in the image. Mark the assumed number as shown in the image. Now, write zeros and plus on the hidden sides of the strip, which represent the place values. Fold the strip as shown in the image. To read the number written on the strip, expand. We have observed that the given number is 4,53,281. We need to know the zeros of the place values first to know the numbers. Only then we can easily find what is the number and its place value. In this section, we are going to learn about using of commas in appropriate places in large numbers. We have often used commas while writing numbers. Commas help us in reading and writing large numbers. In our Indian system of numeration, we use ones, tens, hundreds, thousands, and then lakhs, crores, and so on. Let's see the conversation between teacher and student on usage of comma. What is a comma? Comma is a punctuation mark indicating a pause between parts of a sentence or separating items in a list. How to use it? Let us go into details of using commas in numbers. See the number shown on the screen. Here, the first comma should come after hundreds place. That is, 3 digits from the right and marks thousands. The second comma comes 2 digits later. That is 5 digits from the right. It comes after 10,000's place and marks lakh. The third comma should come after 10 lakhs place and marks crore. Varun, read out these numbers using commas. 5 crore 78 lakh 97,451. 89 crore 24 lakh 56,321. 78 crore 65 lakh 46,632. Let us perform an activity to context the number names to figures and place commas in proper positions. The cost of each item is displayed on the screen. Convert the number names into numericals and place commas in proper places. Then sum up all the numbers. What is the number will you obtain? The first one is done for you. Till now, we have learnt about Indian system of numeration. Now, we are going to discuss about international system of numeration. What's the price of a car? 1 lakh. I didn't get you. What is 1 lakh? Up to 10,000, the number system is same in all countries. But in India, 100,000 is called a lakh. Thank you. Could you please tell me some more numbers? Yes, of course. 10 lakhs is 1 million. Crore is 10 million. 100 crore is 1 billion. The following table show the place values of Indian and international number systems. Now, let us see the international system of numeration of using commas. In international system of numeration, we use ones, tens, hundreds, thousands, and then after millions, billions, trillions, and so on. Here, comma comes after every 3 digits from the right. Let's see an example by using the International System of Numeration. Suppose the number is 53635798. In Indian System of Numeration, it can be read as 5,36,35,798. In International System of Numeration, it can be read as 53,635,798. Let us perform an activity on Indian and international systems of numbers. Select the appropriate options for the following blanks.
Knowledge check. Attempt the following questions to check your understanding.
Let us now learn about large numbers used in our daily life situations to measure lengths. As we know that meter, which is denoted by m, is a unit of length. If we want to measure the distance of the school from your home, we use kilometers, km. If we want to measure the length of a pencil, we use centimeters. But if we want to measure the thickness of a cardboard, we use millimeters. For example, 10 millimeters is equal to 1 centimeter. 100 centimeters is equal to 1 meter. 1000 meters is equal to 1 kilometer. By this, we can convert and use as per our requirement. Let us see where to use kilometers, centimeters and millimeters. Click the appropriate options for the following blanks. Large numbers used in our daily life situations to measure weights. In the same way, we buy rice or wheat in kilograms. But if we want to buy small quantities, we use measurements like milligrams, grams. Let us see the relation between them. 1000 milligrams is equal to 1 gram. 1000 grams is equal to 1 kilogram. Let us see where to use kilograms, grams and milligrams. Click the appropriate options for the following blanks. Large numbers used in daily life situations to measure liquids. For measuring liquids, we use measurements like liters, milliliters and kiloliters. Let's see the relation between them. 1000 milliliters is equal to 1 liter. 1000 liters is equal to 1 kiloliter. Let us see where to use kiloliters, liters and milliliters. Click the appropriate options for the following blanks. Estimation and rounding off numbers. In our daily life, we come across many situations such as 500 students nearly assembled in a school prayer. 15,000 people approximately visit Ramoji Film City daily. 10,000 tons weight roughly lifted by a heavy crane. The words nearly, approximately, roughly are used to show that something is almost near the number but not completely. In fact, 15,000 may be 14,957 or 15,154. That is, it may be little less or more, but not exactly the stated number. Estimation is also a good way of checking answers. We usually round off the numbers to the nearest tens, hundreds, thousands, and so on, etc. Look at the example which is shown on the screen, rounding off the numbers to the nearest tens. 51 is near to 50 than 60. So 51 is rounded off to 50. 56 is nearer to 60 than 50. So it is rounded off to 60. Here let us estimate the numbers to their nearest hundreds. To estimate the nearest hundred of any number, we need to examine the tens place of the digit. Suppose the tens place of the digit is less than 5, then replace tens and ones digit place of that number by 0, keeping all the other digits same. If the tens place of that digit is more than or equal to 5, then replace tens and ones digit place of that number by 0 and increasing the digit at its hundreds place by 1. For the number 9476 as number 7 at its tens place is more than 5, we need to increase its hundreds place by 1, keeping the tens and ones place digits as 0. Thus, the rounded off number is 9500. Similarly, for the number 456, the nearest hundred is rounded off by 500. Here let us estimate the numbers to their nearest thousands. To estimate the nearest thousand of any number, we need to examine the hundreds place of the digit. Suppose the hundreds place of the digit is less than 5, then replace hundreds, tens, and ones digit place of that number by 0, keeping all the other digits same. If the hundreds place of the digit is more than or equal to 5, then replace hundreds, tens, and ones digit place of that number by 0 and increase the digit at its hundreds place by 1. Let us consider another number 8792 in which the hundreds place is greater than 5. So the hundreds, tens, and ones digit of that number will be replaced by 0 and the thousands place of that number will increase by 1. Similarly, in the number 14,571, the hundreds place of it is 5, so increase the digit at thousands place by 1 and replace the digits at hundreds, tens, and ones place by 0 to get the rounded off numbers. Let us do a simple activity on rounding off the numbers. Round off the following numbers to the nearest tens, hundreds, and thousands by clicking the appropriate option. Let us estimate the outcomes of situations based on numbers. We know that while adding two or more numbers, we first add the digits in units place and carry the appropriate number, if necessary, to the tens column. Similarly, while adding the tens column, if necessary, carry forward the appropriate number to the hundreds place, and this goes on. But this way of calculation takes time and it cannot be used in situations where we need to find the answers more quickly. That is, for example, if you go to a supermarket and buy many varieties of groceries at that time, it will be difficult to calculate the cost quickly. Similarly, we find many situations where we need to find the cost, like Raja's mother estimates the cost of monthly expenditure for their family. Sandeep estimates the rounded off cost of their Chennai trip with his friends and many others. Do you think the rounding off will be at the same place values for all the numbers? Obviously no. There are no specific rules to estimate the rounded off values of any number. Rounding off a number depends on the degree of accuracy required and how quickly the estimation is done. Let us go through the topic to estimate sum or difference. We use rounding off of numbers in many situations. Suppose you purchase a milk packet for rupees 10.25. Then the shopkeeper will round off the number to rupees 10. In the same way, if you buy groceries for rupees 1399, then its rounded off value will be rupees 1400. So when you estimate the numbers, sometime we might add or subtract those numbers. In such situations, we have to have an idea of why to round off the numbers and to which places the two numbers are added. Let us consider a situation where you have to buy two shirts costing rupees 399 and rupees 279. What is the estimated cost of these two shirts? If we round off to the nearest hundreds, we get as rupees 400 and rupees 300. So, the estimated cost of these two shirts is rupees 700. Similarly, let us consider the numbers 5673 and 436. Estimating both these numbers to their nearest greater place values, we get 6400. Here the estimation difference of these two numbers is 5600. But it is not close to the actual difference, so it is not reasonable to estimate. For that reason, let us estimate its rounded off values to their nearest hundreds. Thus, 5673 rounds off to 5700 and 436 rounds off to 400. Therefore, the estimated difference is 5700 minus 400 equal to 5300. Here we are going to discuss how to estimate products. In order to estimate products, the required values should be rounded off. For example, to find the estimated product of 23 and 91. 23 is rounded down to 20 and 91 is rounded down to 90. Thus, the estimated product is 20 into 90 equal to 1800. Similarly, to find the estimated product of 358 and 326. Round off the number 358 to the nearest hundred, that is 400, and round down the number 326 to the nearest hundred, that is 300. By further solving, we get 1,20,000 as the estimated product.
Let us solve a few exercise problems. Click the tab to view solution.
Now, we shall know about the usage of braces. Once Venkat asked his daughters Shruti, Joshna and Vani to buy apples from a shop. So Shruti bought 5 apples, Joshna bought 9 apples and Vani bought 6 apples for the same cost, that is rupees 10. Then Venkat asked his daughters what is the total amount paid by them. The calculation of these 3 daughters is shown on screen. From the above calculations, we observe that 2 of his daughters got the same result, but the calculation they have done is different and the third daughter has done the calculation in a completely different way. To avoid such confusion, we use brackets. In such cases, we need to put brackets for the total number of apples and then finally, we need to multiply it with 10 as shown on screen. From this, we conclude that brackets help in simplifying an expression that has more than one mathematical operation. If an expression that includes the brackets is given, then perform the operation inside the bracket and change everything into a single number. Then carry out the operation that lies outside the bracket. Here we are going to see how to expand the numbers within the braces. The use of brackets allows us to follow a certain procedure to expand the brackets systematically. Here, to multiply the numbers 12 and 108 in a simpler way, we use braces. That is, initially, we write the number 12 as 10 plus 2 within a bracket and similarly write 108 within the braces as 100 plus 8. Now, using distributive law, let us remove the bracket for the second pair of numbers as shown. By further solving, we get as shown. Similarly, to multiply 18 and 9, we do as follows. Now write number 18 as 10 plus 8 within the braces and multiply it with 9. To remove braces for 10 plus 8, let us multiply each term with 9 using distributive law. By further solving, we get as shown on screen. Let us see how the numbers are represented in the Roman system. Today, most often we use numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 in both Indian and international system for writing the numbers. In the earlier days, the number system was based on certain letters which are given values and are used as numerals. There are 7 symbols used in this system. Each symbol has its corresponding value as shown. I represents 1, V stands for 5, X means 10, L is used for 50, C marks 100, D indicates 500, and M is 1000. All numbers in Roman times would have been written out using these symbols. For example, 17 would have been written as 10 plus 5 plus 1 plus 1, which is equal to XVII. The Roman numerals for the numbers 1 to 15 are shown on the screen. For the number 0, there is no symbol in Roman numerals. The Roman numerals are used in some clocks. The usage of Hindu-Arabic numerals came into existence for the following reasons. As multiplication, division, and other complex operations were difficult to perform on Roman numerals. It is also a time-consuming process for the larger numbers. Let us list out the rules for the numeral system. The rules for the numeral system are as follows. If a symbol is repeated, its value is added as many times as it occurs. For example, if the letter I is repeated thrice, then its value is 3. A symbol is not repeated more than 3 times. The symbol V, L, and D are never repeated. If a symbol of smaller value is written to the right of a symbol of greater value, then its value gets added to the symbol of greater value. For example, in case of xi, I is written to the right of x. It means that 1 should be added to 10, hence its value is 11. If a symbol of smaller value is written to the left of a symbol of greater value, then its value is subtracted from the symbol of greater value. For example, in case of IV, I is written to the left of V. It means that 1 should be subtracted from 5, hence its value is 4. The symbols V, L, and D are never written to the left of a symbol of greater value, so V, L, and D are never subtracted. For example, we write 12 as XII and not IIX. The symbol I can be subtracted from V and X only. For example, the value of IV is 4 and the value of IX is 9. The symbol X can be subtracted from L, M, and C only. For example, X is subtracted from L to get 40, which is represented by XL. Do not put the bars above the Roman numerals unnecessarily. For example, to represent 7, write it as VII. If bar is placed on it, its value increases to 1000 times of the numerals values, that is, VII bar equal to 7000. Let us solve some examples on Roman numerals. Write the following numbers in the form of Roman numerals. Let us start with number 80. We can express 80 as 50 plus 10 plus 10 plus 10. As we expressed 80 in terms of addition of numbers, we write the greater number left side, that is LXXX. In the next number 90, we can express 90 as 100 minus 10. As we expressed 100 in terms of subtraction of numbers, we write the greater number to the right side, that is XC. Write the below given Roman numerals in the form of numbers. Initially, let us consider MDLI. We have M equal to 1000, D equal to 500, L equal to 50 and I equal to 1. As the letters are arranged in descending order, so we add all the Roman values, that is 1000 plus 500 plus 50 plus 1, which is equal to 1551. In the next Roman numeral CLIX, we have C equal to 100, L equal to 50, I equal to 1 and X equal to 10. Here the first two letters are arranged in descending order, so we add them as X is greater than I, so we subtract I from X, that is 100 plus 50 plus 10 minus 1, which is equal to 159.
Try to solve the problems in the practice zone on your own. You can click Solution for your reference. Summary. Let us recap the highlights of this chapter.
The words nearly, approximately, roughly are used to show that something is almost near the number but not completely. If two values are equal, we use the equal sign, but if one value is smaller than another, we use a less than sign. And if one value is greater than another, we use a greater than sign. The arrangement of numbers from least value to the greater value of the given numbers is known as ascending order. The arrangement of numbers from greater value to the least value of the given numbers is known as descending order. The numerical value that a digit has by virtue of its position in a number is called place value. Estimating or being able to guess and come close to a correct answer is an important part of mathematics and a very handy tool for everyday life. You should get in the habit of estimating amounts of money, lengths of time, distances, and many other physical quantities. Rounding off is a kind of estimating. The smallest three-digit number is 100 and it follows the largest two-digit number is 99. Similarly, the smallest four-digit number is 1000 and it follows the largest three-digit number 999. By rounding off the value, we can estimate the outcome of any number quickly. To avoid confusion in the problems where we need to carry out more than one operation, we use brackets.
Follow-up work.
Know the population of various countries and try to put commas in Indian system of numeration. Know the highest and smallest of 10-digit, 11-digit and 12-digit numbers.
Test your understanding of the chapter by taking the mock unit test.
You have successfully completed the chapter Knowing Our Numbers.